All right, so for example 2 here, it says find the exact value for each of the following. The arc cosecant of 2. Well, arc cosecant is the same thing as what? The inverse cosecant. And when we're doing the inverse, that means we're looking for the angle. Well, so if I'm looking for the angle, we know that we can use the inverse, just like we did before, and say cosecant of theta then is equal to 2. But what's cosecant the reciprocal of? Sine, right? Two C's don't go together. So if I take the reciprocal of this side, remember what you do to one side, you have to do to the other, so I've got to take the reciprocal of that side. What's a reciprocal of 2? And now this looks like what we were doing in 4.8, doesn't it? So, we got to think about a couple things, though. We're looking at the inverse cosecant, which, what quadrants are my answers going to come from? 1 and 4, okay? The only difference between it and its reciprocal sign, they're both in 1 and 4, but for the arc cosecant, 0 is not included. So we're still going to be looking at quadrants 1 and 4. So sine is what in terms of x or y? So we are looking in quadrants 1 or 4 where y is going to be our 1/2. So where is y equal to 1/2? Pi over 6. Okay, for B, I've already got the inverse secant of the negative square root of 2. So we know that's going to equal theta. So that means that secant of theta is equal to the negative square root of 2. So if I take the reciprocal, what's the reciprocal of secant? So cosine of theta is equal to, what's the reciprocal of the negative square root of 2? Negative 1 over the square root of 2. Now, if I was going to use my calculator, which we're not because it says exact, if I was going to use my calculator, I could just use 1 over the negative square root of 2. It doesn't care, okay? It can handle that. But if I use my ordered pairs, we know that that's not going to be on there. So let's get rid of that radical on bottom. And so we got negative square root of 2 over 2. Now we're talking about the arc secant. So we're looking at quadrants what? 1 and 2. And I said arc. Sorry, I meant inverse. Same thing, but I know we're used to hearing inverse secant.
How do you all know that it's those quadrants? Yeah, that's what she said.
Okay, so we're looking for where cosine is a negative square root of 2 over 2 in either quadrants 1 or 2. So what is cosine in terms of x and y? It's our x. So we're going to go find in quadrant 1 or 2 where x is a negative square root of 2 over 2. Good, 3 pi over 4. All right, so the arc on D, it says the arc cotangent of 1. Well, we know that arc cotangent is the same as the inverse cotangent. I don't know why I wrote that. I don't know. In the orange folder. Which means that cotangent of theta equals 1, correct? Now, inverse cotangent, where are we looking for its answers? No, remember, the inverse cotangent is the one that's different. If you look at where its answers are going to be, it told us it's going to be from 0 to infinity. So we're going to start looking in quadrant 1, and if our answer's not there, we're going to go into quadrant 2, and if it's not there, then we go into 3, and if it's not there, we go to 4, okay? So,
we don't use tan on this one?
yeah, I'm going to. So, we need to, what, take the reciprocals? So the reciprocal of cotangent is tangent, and the reciprocal of 1 is 1. So I want to know, well, what is tangent in terms of x and y? So where is y and x going to divide and give me a 1? Well, when is the only time I can take a number divided by a different number and get 1 out of it? If they're the same number. I tried to trick y'all. I said different number, but that didn't work. All right, so I'm looking for where x and y are the same number. So look in quadrant 1. Does it happen there? Yes, at pi over 4.